Alright, ladies and gentlemen, I'd like to welcome you to another installment. Physics for Military Aptitude Testing. I'm Kieno Thomas from Kieno Training Systems. Today we are going to talk about collision. A collision occurs when two or more objects hit each other. When I talk about the word collision, you're probably going to think about or be reminded of maybe like two cars colliding or experiencing a collision with each other. Collisions not only occur then, but collisions occur when we hit a tennis ball, when our feet hit the ground, even when we type. During a collision, momentum and energy are transferred from one object to another. Different factors like mass, initial velocity, and type of collision determine the direction of objects after they collide. There are two types of collisions that we deal with, basically. One is an inelastic collision, or elastic. So here's an elastic collision, and there's an inelastic collision, the egg. In an elastic collision and an inelastic collision, objects change or they stick together, and the total kinetic energy of the system decreases. Not so much in the elastic collision. We keep most of the kinetic energy. This leads us into our question. I was just trying to, alright, so we have a elastic collision here, and here's an inelastic collision. That's an inelastic collision, so you can see the difference. In an elastic collision, nothing really changes shape, as opposed to an inelastic collision, something is going to change shape after the two objects collide. So this is going to lead us into our question. Alright, two objects are about to experience a head-on collision. Two objects in this collision, one is 15 kilograms, moving at 5 meters per second to the left. And man, this slide thing's acting funky today. Alright, and then we have a 30 kilogram object moving 10 meters per second to the right. So we have two objects are about to experience a head-on collision. And assuming that we have a completely inelastic collision, what is the final velocity? Now I know this question is a little weird. Nothing is going to change shape here. So I don't even know why the question was posed like that, but that's okay. We'll get past that. Basically what we want to know is what's going to happen to this 15 kilogram object at the end of the collision. So we can automatically kind of assume that this guy is bigger. Force equals mass times acceleration. The mass is 30, acceleration is 10 meters per second. So it's bigger, and it's definitely going to result in pushing this guy to the right. But how far, and well, not how far, but how fast after the collision is it going to move to the right? Alright. Now, this guy is one of our answers. Will it move at A, 5 meters per second to the right? B, 5 meters per second to the left? We could throw that out because this is a bigger object, and it's definitely going to transfer its energy to this ball and possibly drive it into the opposite direction. 15 meters per second to the right, or D, 15 meters per second to the left. Now, I'm gonna reiterate. This is bigger, and it's probably gonna drive this object to the right. So I would throw out B and I would throw out D. As we calculate this, we need to think about the number line. So when we put this into a formula, we need to think of the directions as positive and negative. Alright, so since this force is going to be transferred or translated to the left, we're going to assign 5 meters per second a negative number. We're going to make that a negative number because it's going in this direction. So I put the number line up here to kind of give you an idea of why we are doing that. Alright, so we've assigned that a negative symbol. And just looking at my talking points, the equation has 1 times the velocity mass and blah, 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 blah. You can read that on your own. But this is basically the equation. The mass of object 1 times the velocity of object 1 plus the mass of object 2 times the velocity of object 2 is equal to mass of object 1, 15 kilograms, plus the mass of object 2 multiplied by V result. Just means it's going to give us how fast we're going to be moving in meters per second afterwards. Now again, we're going to assign a negative sign to this object on the meters per second side because it is going in the left direction. And I put the number line here again because I want you to know that whenever we move in this direction from right to left, it's going to be assigned a negative number. And we're going to pause here for a sec. So now we plug in the numbers. Mass 1, 15 kilograms. Velocity 1, negative 5. And I should also have a negative 5 there. And what else? Alright, mass 1, velocity 1. Mass 2, 30 kilograms. Velocity 2, 10 meters per second. Equals mass 1 plus mass 2, 15 plus 30 kilograms. And that's going to give us what I call V result. So we plug the numbers in here. 15 kilograms minus 5 meters per second. 30 kilograms times 10 meters per second. 15 kilograms plus 30 kilograms. And then we'll come up with V result, which is the resultant energy. Now what happens here is 5 times 15 is going to be negative 75. And then 30 times 10 is going to be 300. So we're going to wind up with 225. And that's going to be divided by 45, which is 15 plus 30. And we divide that so we can isolate V result by itself. And our result is going to be 5 meters per second to the right. That is what's going to happen after the collision. This object is going to roll 5 meters per second to the right. So that was our little short video explaining collision, elastic, and inelastic, and we worked out the collision problem. So I'd like you to hit the subscribe button below, and share in your social media networks. And I'd like to thank you guys for watching. Today is Turkey Day. Eat some turkey, but not too much. Thanks for watching.